All right, we're looking at ordering rational numbers today, guys. We've got the same goal, and now we're getting right into it. Compare, order, and define rational numbers, and then we're going to get into performing operations with rational numbers. So first, we'll grab this page that I've given you a link to. You'll see here we've got our definition of rational numbers, and I like this because this page has got some examples for us too. This is a real number that can be written as a simple fraction. 1.5 is a rational number because 1.5 is equal to 3 over 2. A few more examples here in the table. 5 over 1, 7 over 4, 1 over 10,000, 1 over 9, all rational because they create decimals. Irrational numbers that are not rational would include the square root of 2, and down here a famous irrational number is pi, 3.1415. It keeps going and going. We can't really define it neatly and nicely as a fraction or as a rational number. All right. Next so a more formal mathematically correct definition for us is that we can think of a rational number as a number that can be in the form p over q, right? Can be in a fraction form where p and q are integers and q is not equal to 0. And you might come across some stuff like that where we've got the denominator as 0 and that doesn't work. It's not a real number. We can't divide by 0. And your calculator will tell you that if you try it. So that's the definition of these guys, and you'll see it and you'll get to know and understand these rational numbers in the work you're doing. One important thing to think of is just sort of the form of rational numbers, and we said they're integers. We're writing as a fraction form, so this would be 3 divided by 4. It could be negative 3 divided by 4. Could be 3 divided by negative 4. So you might actually see that negative sign sort of pulled out. Those are equal, right? They'd also be equal to this. If we're talking about 3 divided by negative 4, all three of those things are equal. What this is not equal to is this is not equal to a negative 3 divided by a negative 4. And if you remember your integer rules, that's actually equal to 3/4. They're both equal to 0.75, and it would be equal to a positive number because negative divided by a negative gives us a positive. So this guy has no sign here. Right, but in terms of form, be thinking of that, be cognizant of that. You are going to be seeing some integers, positives and negatives, here with rational numbers. Another thing you're going to see is opposites. Again, just be aware, just be cognizant of the fact that, a negative 5 is the opposite of 5. Right? Negative 3/4 is the opposite of 3/4. You're going to be using that idea, working with that idea, as you begin to define rational numbers for yourself. The bulk of what we're going to do here as we get started is going to be ordering, but perhaps one more thing, again, in terms of form. we were working with some of these fractions, and actually I threw in the example up here of the negative 0.75, but remember negative 3/4 is equal to negative 3 divided by 4. So on your calculator, if you just punch that in, that's how you get your decimal form, right? So top divided by bottom gives us the decimal. Another thing just to kind of make a note of there, just so you remember, you realize we can still do that. We're going to be doing that. So some ways to order these guys. Let's create a list for ourselves. So let's talk about negative 1.2. Let's talk about 4/5. Let's talk about 7/8. Let's talk about negative 0.5. And let's make a repeating decimal. So that would be like a 5555. And perhaps negative 7/8 as well. One way to order these, to decide which is bigger, which is smaller, would be to make some decimals. So this we could make into 0.8. We had our negative 1.2 here at the beginning. We could make this into 0.875. We divide top by bottom. Negative 0.5 repeating, and then positive. Oh, sorry, this is the negative 0.875. So we'll just pause for a moment here, and we'll arrange these guys so you can do it yourself. Alright, so you may have ordered them in either of these ways. And I was ordering the originals in ascending order. You can take a look at that. We're starting at the smallest, the negative 1.2, and we're working towards the largest, the 7/8. Descending, going down the stairs, you can think of. We're starting at the largest, going down to the smallest. Okay, two ways to order rational numbers. another thing to think about here, another thing we want to be able to do is identify a fraction between some rational numbers. So between, say, a negative 0.6 and a negative 0.7. And there's two ways you might do this. But again, this is kind of part of building that definition of what these rational numbers are. So you're going to see some number lines in this section of the text in your practice work here. From 0 to negative 1, we'd put our negative 0.6 here, and our negative 0.7 somewhere in about there. And again, it's sort of part of the definition of these guys. So in here, we're looking for a number that's between 0.6 and 0.7, so we've got to think to ourselves there's going to be a 0.61, 0.62, 0.63, and so on. So something exactly in the middle would be the negative 0.65. That's one way to think about this. Another way to think about this, using number lines. A second strategy that you want to be comfortable with, we're going to use here to practice here, is visualizing these or working with these using fractions. So that negative 0.6 is 6/10, and it's negative. The negative 0.7 is 7/10, and it's negative. We could also think of this as 60/100ths and 70/100ths. And sorry, let's not forget our negative signs here. So in between would be 65/100ths. All right, that's the last thing we're going to work on today. Your assignment is from 2.1. Choose 7. Good luck.